Hello ladies and gentlemen, this is Mr. Green and this is Geometry, and I just wanted to point out that we have finished Unit 1 and are now moving on to Unit 2. Unit 2 deals with proofs and logic, okay? So you should all have either taken all the quizzes and be working on the unit exam or have completed the unit exam. Don't forget, you can always make quiz corrections and get those things taken care of. Due dates. They're due the day they're assigned, and you've got till that Saturday, or that Sunday really, to get them in without me putting a 0 in the grade book. But you've got 28 days after the 0 goes in for that grade to then for you to make up that grade, because if you make it up in that 28 days, it'll replace the 0. So make certain you get that done. Don't forget, quiz corrections are always available to any grade in the course except for discussions and the Part 2 exams. Okay, so where are we? We're looking at informal proofs, or we're looking at proofs in general. One of the first things that you're going to discover is there's a formal way of writing a proof and an informal way of doing it. Okay? Informal logic relies on inductive reasoning. Inductive reasoning is simply looking at something and looking at the pattern that it is making, and then concluding from that pattern what the next one is going to be. Okay? For example, if you roll a dice and you roll a 7 4 times in a row, then the ideal situation was I'm going to roll this dice and get a 7 the next time I roll it. That's how come Vegas makes a ton of money, because it doesn't really work that way, but that's what inductive or informal proofs are. Okay? Inductive reasoning is the logic that was used by Isaac Newton when he came up with the theory of gravity, because he looked at an apple as it fell off the tree, and he looked at another apple as it fell off the tree, and he said there must be some force pulling those apples from the tree to the ground, and he came up with a concept that he called gravity. Okay, and that's where the inductive informal proof is the way they have proven, or they have stated, that there is gravity. Now, inductive reasoning. If you roll a pair of dice on a board game 5 consecutive times in a row, each time getting a result greater than 7, you conclude your next time you roll the dice will be greater than 7. That is inductive reasoning. You record the temperature outside your room at noon for a month. The highest temperature recorded is 58 degrees. You conclude that the temperature outside your home will never reach 75 degrees. We all live in Texas. We know it gets hot down here. So we know that's false. But if you looked at the temperature in the middle of winter and it never got above 58, you could conclude this using inductive reasoning. Not necessarily sound in either one of those two cases, but it is a form of reasoning. Inductive reasoning. You place a can of soda in your freezer for 30 minutes. You place another can of soda in 15 minutes later, leaving the first can in place. You continue putting cans of soda in the freezer every 15 minutes. When you check the can that was left for an hour and 45 minutes, it explodes. You conclude the pressure inside the freezing can of soda becomes greater than the pressure outside it at some point between an hour and 30 minutes and an hour and 45 minutes. This is sound inductive reasoning. You can conclude that. It makes sense and it's repeatable. But the first two examples, not so. So what can we say about inductive reasoning? Inductive reasoning is not bad. Inductive reasoning gives us a premise. That's what this is saying right here, a premise. Okay? And then we can step into a formal logic approach. We can go into a more formal approach. Take that premise and some sound reasons, some sound premises to back it up, some sound statements behind it, and come up with a conclusion. That is the basis for a proof. Starting with a premise, using logic and reason behind it, and coming up with a conclusion. That is what you are doing with a argument, with the proofs. Valid arguments are done in one of two methods. Okay? A valid argument is one in which its true conclusion must follow logically from true premises. Valid arguments often follow certain patterns of logic, and there are two patterns of logic that you need to know exist. The first pattern of logic is called the law of syllogism. The law of syllogism is something that is simply saying if A is true, then B is true. Okay? If B is true, then C is true. Therefore, if A is true, C is true. Now, you heard me saying all that, and there's not a single if or then on this screen. That's what this arrow's doing. If A, then B. Okay? If B, then C. And therefore, that's what these three dots mean. Therefore, if A, then C. And I want you to notice, what have I done? For the law of syllogism, there are three if statements. Okay? In these three if statements, the middle is eliminated. Middle, M-D-D-L-E. I'm sorry, I cannot write with a mouse. It never has one. The middle one is eliminated. What am I talking about here? See the B right here? This B? It is eliminated in the final statement. I went from A to C, and I'm eliminating B in between. It's like skipping a step in an algebra statement. And last year, I know your algebra teachers were saying, show all your work. That's because in math, you show every step of the way. And when you start skipping steps, you start making mistakes in the first place, but it's harder to grade your work. That's what the law of syllogism is. Don't skip a step. You've got that B in the middle, and therefore you've got A is now, if A, then C. This is a typical logical approach. It makes a valid logical argument. I didn't say true. I want you to notice I didn't say true. Very careful about this. It's not making a true logical argument. It's making a valid logical argument. Law of syllogism is simply valid or invalid. The other law that we use for a valid argument is the law of detachment. And in this one, there is only one if-then statement. It says, if A, then B. Okay? If A, then B. We know A is true, therefore B must be true. That's all it's saying. Now you can tell these two apart because this one has one if statement. Okay? The other one had three if statements. So if I'm trying to determine, is this a law of syllogism or the law of detachment, I'm counting the number of if statements. If I see one, it's detachment. If I see three, it's syllogism. That's simple. Nothing more to it. Don't add anything else to it. That's how simple it is. If I say it's law of syllogism, I have to verify it's law of syllogism, make certain that B, that middle one, is being eliminated. It has to be the end of one and the beginning of the other one. If statements. The end of one if statement, beginning of the second if statement. If it's eliminated in the third if statement, then it could be the law of syllogism. Law of detachment. If A, then B. I can't say B is true, therefore A is true. I have to say A is true, then B is true. Only one if statement. Those are valid argument types. That's what we're saying here. Valid or invalid. So here are some questions. If you go to the movies on Tuesday, then you will get a ticket at half price. If you get your ticket at half price, then you have enough money for 2 tickets. Therefore, if you go to the movies on Tuesday, you will have enough money for 2 tickets. I am going to show you. I'm counting if statements here. 1, 2, 3. That means it has to be the law of syllogism that I'm looking at. And I'm looking at the then statement here says, you will get your ticket at half price. That means it has to be the beginning of the next one. You will get your ticket at half price. Therefore, what am I saying? If you go to the movies on Tuesday, then you'll have enough money for 2 tickets. That's what this statement says. This is valid, okay, by the law of syllogism. Syllogism. Yes. Put this there. Law of syllogism. Okay? So let's look at another one. See if it's valid or invalid. If Pete's Petite Pet's Palace is open on Sunday, then I'll buy a hamster. Pete's Petite Pet Palace is open on Sunday, therefore I will buy a hamster. Let's look at it. How many if statements do we see? 1. Must be the law of detachment. If it's the law of detachment, this statement has to be true. And there's right here, they're saying it's true. That means this statement will be true. Then I buy a hamster. I will buy a hamster. Therefore, this is valid. You notice I'm not saying true or false. I'm saying valid by the law of detachment. Okay? Everyone following what I'm saying here? Okay? How about this one? If an animal is a dog, then it barks. If an animal is a dog, then it has 4 legs. Therefore, if an animal barks, then it has 4 legs. Counting the if statements, how many if statements do I see here? 1, 2, 3 if statements. That means it must be the law of syllogism. So if it's the law of syllogism, I have to take the then. It says, then it barks. And that has to be the first statement. Wait a second. That's not the first statement here. That's not this one. That means this is invalid. Invalid by the law of syllogism. It doesn't meet the law of syllogism. Can you see what I'm doing? Now, I want to tell you, in life, you're going to run into people that are going to try to convince you to buy things. You're going to run into people that are going to try to convince you to do certain things. You're going to run into people that are going to do different things every time you turn around. Okay? That different thing they're trying to do, a lot of times they're using invalid logic to get you to get there. And if they're using invalid logic, that means they're going to try to convince you to do something you don't really want to be doing. Okay? So this week we were looking at this stuff right here. Okay? This is where we're at right here. Reasoning and argument of proofs. Okay? So we're looking at right here, making conjectures about angles, polygons, choosing from a variety of approaches as coordinate transformation, axiomatic, and using two-dimensional coordinate systems to represent points. How did we do all that? We're doing all that through logic. Okay? And we're trying to get better at using our logic. Now, I do have a pause. No, I don't have a attendance link. I will only do attendance during Class Connects. You can watch these videos all you want. Okay? So I'm not going to, there is no secret word for this one. Okay? Already done that. So when you're talking to me, make certain you're giving me the course and the section number. I have 12 sections of geometry, so I need to know which one you're in so that I can keep track of it and I can find your name quicker and I can get answers to you much quicker. So looking for that information before I can respond. Anytime you're K-mailing me, anytime you're IMing me, give me that information. I would appreciate it. I appreciate it, guys, and I'll talk to you later.